Good evening, students. I hope you are all well. Today, I am going to discuss control chart. Now, you know that control chart is an important device for statistical quality control. Now, what is a control chart? A control chart is a statistical device that is used in controlling the manufacturing process and is a kind of graphical chart used to detect any unusual variation occurring in the process of production that may put the process out of control. So you have to remember this definition. Now there are various types of control charts. It may be broadly classified into two types, that is control charts for variable and control chart for attributes. So type of control charts are of two types. Control chart for variable, that is measurement chart or variable chart, and control chart for non-measurable characteristics, that is attribute chart. Now you know that variable can be measured in terms of unit, whereas attribute cannot be measured in terms of units. So variable chart, what is variable chart? Variable chart controls the quality characteristics of a product which are measurable and can be expressed in specific units of measurement, such as diameter of a steel rod, weight of a chemical component, tensile strength of cement, etc. Now, what is attribute chart? Attribute chart controls those quality characteristics of a product which are not amenable to measurement, that is, which cannot be measured or which are not measured for economy. Such characteristics can only be identified by their presence or absence from the product. For example, number of blowholes in a casting and number of defects in painting work, etc. Now, the types of variable charts. Variable charts are of three types. Number one, mean chart, that is X bar chart. Number two, range chart. You know range. What is range? Range is the highest value minus lowest value. So range chart, that is R chart, and standard deviation chart or small sigma chart. Clear? Now, what is mean chart? What are the control limits for mean chart? What are the control limits for range chart? We have to know. Now see, control limits for the X bar chart, that is upper control limit equals to X double bar plus A2 R bar, where X double bar is the mean of the whole process, and R bar is the average range, and A2 you will find the value of A2 is a constant. You will find the value of A2 from the table. Now central line equals to X double bar. It is also called as center line. Now lower control limit equals to X double bar minus A2 R bar. So these are the control limits for X bar chart or mean chart. Now control limits for the R chart. Upper control limits for R chart equals to D4 into R bar. Central line equals to R bar, and lower control limit equals to D3 R bar. And the value of A2 or D3 or D4 can be found from the table, or the value of D3, D4 or A2 will be given. Now this is the table. Now see, this is the table. You can also go through this table. Here, number of units in a sample. If the number of units in sample is 2, then A2, the value of A2 is 1.88, D3 equal to 0, D4 equals to 3.27. So if the number of sample is 5, then it should be A2 will be 0.58, that is 0.577 actually. Here 0.58, and D3 equal to 0, and D4 equals to 2.11. And when below when the value of sample is 7, then the value of D3 will be 0.08. Below 7, for all the samples, the value of D3 will be 0. So we have to take the help of this chart or of this table. Clear? Now see, we have already discussed the control limits for the R chart and control limits for the X bar chart, and control limits for standard deviation chart. Here upper control limit is sigma, that is standard deviation into B2, and lower control limit equal to standard deviation into B1. But where standard deviation is not known, then we get a S bar, that is summation of standard deviation of sample by number of samples. Here upper control limit will be B4 S bar and lower control limit equal to B3 S bar. But here we should not discuss further on sigma chart or standard deviation chart, because it is not so important for our curriculum. Now attribute chart. Now we have to discuss attribute chart. Attribute chart may be of the following types. So variable chart are of 3 types and attribute chart may be of 4 types. Number 1, control chart for fraction defectives and or for percent defectives. It is known as P chart. Number 2, control charts for number of defects. That is, here number of defects, here fraction defectives. So control chart for number of defects is also known as NP chart, and control charts for number of defects per unit. Remember, here number of defects per unit, but here number of defects, total number of defects. Clear? So control charts for number of defects per unit or C chart, and variable P chart, that is also known as U chart. Now I have to mention one point, that U chart is also of another type. That is, we measure the number of defects per unit, but when it is considered only for 1 unit. But if we consider for more than 1 unit, then also we can use U chart. Clear? So see here. See here the control limits for the P chart. Central line equals to P bar. Upper control limit equals to P bar plus 3 into root over P bar into 1 minus P bar by n, and lower control limit equal to P bar minus 3 into root over P bar into 1 minus P bar upon n. Now you have to remember this formula. Here P bar is the ratio between the total number of defective products observed in all the samples combined and the total number of products inspected. Clear? Now control limits for the NP chart. Central line equal to n P bar. Here P bar, only P bar, but here we have to multiply the number of samples, that is n P bar, and upper control limit equal to n P bar plus 3 into n P bar into 1 minus P bar. Clear? And lower control limit equal to n P bar minus 3 into root over n P bar into 1 minus P bar. Now control limits for the C chart. Central line equal to C bar, where C bar equals to total number of defects by number of units observed, that is average number of defects. This is the average number of defects. Upper control limit equals to C bar plus 3 into root over C bar, and lower control limit equal to C bar minus 3 into root over C bar. Clear? Now control limits for the U chart. Control limits for the U chart. When it is a variable P chart, then central line will be P bar and upper control limit equal to P bar plus 3 into root over P bar into 1 minus P bar by Ni. What is the difference between this formula and this formula? Here only N, but here Ni. That is, for each sample, the size of the sample differs here. So it is Ni. So for sample 1, if it is 10, for sample 2 it may be 12, or sample 3 it may be 15. In this way, here the number of samples changes, and here all samples numbers are same. So here lower control limit equals to p bar minus 3 into p bar into 1 minus p bar by ni. Now you have to see one point, that this part. Now see the U chart. Here U chart is the average number of non-conformities. Average number of non-conformities. So it is also known as U chart. In case of C chart, we assume a 1 unit sample size. Please remember, for C chart, we assume a 1 unit sample size. However, we can increase the sample size, in which case when we create the chart, we have to consider average number of non-conformities. If we find X total non-conformities in a sample of n inspection units, then the average number of non-conformities per inspection unit is U equal to X by N. And in that case, control limits for U chart will be upper control limit equal to U bar plus 3 into root over U bar by N, central line equal to U bar, lower control limit equal to U bar minus 3 into root over U bar by N. And U represents the observed average number of non-conformities per unit. Okay, so today we have discussed all the control charts, that is control chart for variable, control chart for attributes, and there are 3 types of control charts for variable and 4 types of control chart for attributes. So in the next class we will discuss the numerical problems on various control charts. Okay, thank you.